Okay, so in this video we're given this diagram here. So we've got a straight line which meets this circle at a tangent we'll call T, and then from here to the origin is 6√5. The circle is 4 in radius and the centre point is Q. Okay, and we're given the coordinates of Q is 11, K. So X is 11, Y will be K. So we need to find out what K is. And what we need to also find out is equation for the circle C. So first things first, let's find K. So K is the Y coordinate. So K will be somewhere down here. So that's where K is. Okay, so how are we going to find that? Well, the way to find that will probably be the best way will be to make a triangle from point Q to the origin. So if I can just draw a nice little straight line there, best I can, straightish, but that will do for now. This here will be a right angle. So maybe we can use Pythagoras Theorem if we can find two of these sides. Well, what we do know is the X coordinate is 11. So this is 11. So that's OK, we'll call that one. QK we don't know, and OQ we don't know. But what we do know is that this line here is a tangent to the circle. So therefore, we've got a right angle here. So if this is a right angle, we know two of the sides. We can use Pythagoras Theorem for this one, and then plug that answer in with this one and get this side. Okay, so what have we got here? So we got 6√5 and 4. So if we call this one OQ, okay, so OQ, let's have a look. What we can say is, by Pythagoras Theorem, Pythagorean theorem, that OQ squared equals 6√5 squared plus 4 squared. Okay, so as OQ is opposite the right angle, that's our hypotenuse. So that one will equal the sum of these two squares. Okay, let's not put the square there, let's put the square properly there. Okay, 6√5 squared. 6√5 squared is found by squaring both of these terms. So if I just put that there, 6 squared is 36, and then we multiply that by 5, square root of 5 squared, which is just going to cancel out that, which just give us 5. And then we add 4 squared. 4 squared, 16. Okay, we do this one in our heads. 5 times 36 is 180. 180 plus 16 is 196. But we've got OQ squared. So what we want to find now is the square root of OQ squared is 196 square root of. So therefore OQ equals 14. Square root of 196 is 14. So therefore we can say that this side here is 14. Okay, right, now we're looking good. We've got this side, just need to find this side now. So we call this one QK. So let's just pour a line here. Now we've got these values. So QK by Pythagoras theorem, we can say that 14 is the hypotenuse. 14 squared equals 11 squared plus QK squared. Okay, 14 squared we know is 196, we've already worked that out. 11 squared is 121. So therefore QK squared is going to be 75, isn't it? 121 plus 75 gives us 96. So therefore QK squared equals 75. Square root both sides. We get QK equals, how we can break this down into radicals. So a big factor of this is going to be 25. We know 25 is a square number. So that'll give us 25 times square root of 3. Square root of 25 is 5. So that gives us 5 root 3. So therefore we can say that this side is 5 root 3. Now 11 comma k, we call this, that one there is capital K, we will need a lowercase k here. So we're looking for the length of this. So here is 5 root 3, so hence this one here is also 5 root 3. So therefore k is 5 root 3, i.e. q, let's just write that down here like this, q equals 11 comma 5 root 3. Now we need to find the equation of the circle, so this circle here. So as we know the coordinates of q, we can use this to make the equation for the circle. So equation for the circle is x minus x1 squared plus y minus y1 squared equals the radius squared. So x1 and our y1 will be these. So that's our x1 and that's our y1. Okay, and r, or the radius we're given in here is 4. Well, 4 squared is 16. So what we can write is here, x minus, what's our x1? That's 11. So x minus 11 squared plus y minus y1, it's 5 root 3 squared equals r squared, 16. There we go. That's our equation for the circle. And we know that k is 5 root 3. Okay, there we go.